developing next-generation research and technology, facilitating connections between AFRL industry and academia, unlocking innovation through a culture of collaboration. This is the AFRL Regional Network Midwest.
Historically, new recipes for integrating advanced technologies into high-stakes domains have had a poor or mixed track record. Many promising technologies in the lab actually never get to be used in operations or have really surprising negative consequences. Being able to build a test kitchen that will simulate and help us understand better how they'll transition into real-world operations are likely to positively impact SSA in real-world operations. We have two goals in our project. One, to evaluate multiple recipes for integrating advanced technologies into SSA operations, and two, to develop a repeatable method for Air Force and Space Force operations to use in evaluating the impacts of future innovative technologies. In this first 6-month increment, we will be focusing on stocking our test kitchen with the ingredients and the equipment necessary to discover new human technology recipes.
Activities in space are vital to our daily lives. Navigational devices, communications and transportation systems, and even much of our entertainment relies upon satellites in space. The mission for SSA operations is to ensure the safety of space vehicles performing these functions and to identify and resolve problems such as potential collisions or lost satellites. As the space environment gets busier and as satellites move further and further away from Earth, operators will need new tools to handle the increased traffic and complexity of space operations in the future. With advancements in technology, new AI systems are being developed all the time, but little is known about how to leverage these technologies for SSA. The Air Force and the Space Force will need to develop these recipes for success, if you will, and a workforce ready to design and evaluate the technologies of tomorrow.
The centerpiece of our test bed is a method called Joint Activity Testing, or JAT, which was developed at Ohio State specifically to evaluate how advanced technologies like AI are likely to impact real-world operations. The goal of JAT is to empirically evaluate how the performance of people and technology together changes as a variety of different challenges increase. To do this, we will conduct a human-in-the-loop experiment and graph the performance of the human-machine system relative to the challenge or the difficulty of the scenario. We will then select a set of testing cases which cover a wide range of challenges and collect performance data across this range. We can then fit a statistical model of performance and use this model to compare the strengths and weaknesses among multiple different human-machine teaming strategies. In this example, although people with technology A appear to perform slightly better than people with technology B in the easiest scenarios at the left side of the graph, people with technology A performed much worse than those with technology B at the right side of the graph. Since our last update, we've been working hard to stand up the test bed we'll be using for our first experiment that operationalizes the joint activity testing methodology for space situation awareness operations. Together with our AFRL colleagues, we have designed a set of scenarios to test a range of various challenges, including the magnitude of satellite maneuver, the noisiness of signals, the relevance of additional intel reports, and the correctness of an algorithmic recommendation. Our goal will be to understand how each of these challenges impacts how well people are able to differentiate active satellites from station-keeping satellites. We will be recruiting a target of 30 students to participate in this study, and we will be setting up a dedicated experimental space with the equipment to run up to 6 participants in a single session. We have now received approval from our institutional review board to begin recruiting participants for this study, and we will be conducting a small pilot to test out our experimental procedures with the goal of fielding the first experiment by the end of this project's first year. Well, here we are. The stage is set and we are ready to run our first experiment. In less than a year, we have developed a brand new joint activity testing capability for assessing space situation awareness operations. At the time of this recording. We are actively scheduling participants for this first study, and we look forward to sharing with you the results very soon.